Alright guys, so let's have a look today at what we call the Earth's spheres. And these are the different interacting sections of the Earth, chemical sections really. So these are where we're at basically. Up here we've got the atmosphere, that's the air, and above the air. So that's that area. Then we've got the hydrosphere, that's everything with the water in it. The biosphere, this is the living part. You are part of the biosphere, so it's all of the Earth's biomass. And then you've got the lithosphere. There's essentially the crust and the upper mantle. So the rocky parts. Now, what you'll see is that the lithosphere interacts with the atmosphere. It also interacts with the biosphere and the hydrosphere as well. You know what? There's no direct one there. Let's make one happen because it interacts with the hydrosphere as well. Because the water percolates the rocks and the salt in the ocean comes from rocks being dissolved and so forth. The biosphere, you breathe in the rock. Sorry, don't breathe in rock. That'd be silly. You breathe in the air. You breathe in the air. Let's stick with that one. You drink the hydrosphere. You take in minerals from the lithosphere in your vegetables, etc. And meats as well, because they've eaten the vegetables. So let's have a look at them. Essentially, what is actually the lithosphere made up of? Well, it's made up of about 46% oxygen and 27% silicon and aluminium, and you see a bunch of metals. And what you'll notice is that a lot of these metals are mined out of the ground, because that's where they come from. Iron is the most common element in the whole Earth, and there it's followed by oxygen and silicon and magnesium and nickel. The core of the Earth is essentially iron and nickel, but the lithosphere, oxygen wins that race. The hydrosphere. The hydrosphere itself is various mixtures, but if we wanted to look at the abundance of percentages of each one, clearly in the lithosphere, it's going to be oxygen and hydrogen, because they make up this molecule, which is, we'll put an H there, we'll put an H there, and we'll put an O there. They make up water. So it makes sense that they're the most common parts. And then we've got chlorine and sodium, the salty water of the oceans. That's the majority of the water. And then you've got magnesium in there as well. In the atmospheric mixtures, if we dry gases from the troposphere, troposphere is where we breathe, and the reason we dry them is to take the water from the hydrosphere out of it. It is 78% nitrogen. This is by volume, but by mass, and this is so this means by volume, percent of the volume, and this means by mass. Okay, so about 75% nitrogen, about 23% oxygen, and then argon. Argon's really important, but it's a noble gas, so we don't breathe it in. Well, we breathe it in, but we don't really use it. And then we go forth, carbon dioxide. That's all the carbon dioxide there is. That's how much of the mass. And it has such a big impact on life on Earth. Now, if we want to look at elements in the living cells, well, this makes sense. There's carbon, oxygen, hydrogen. You are known as a carbon-based life form. Essentially, you're made up of carbohydrates, which is these guys. And then you got nitrogen, which we get from the lithosphere. Calcium, we get from the lithosphere. Phosphorus, and we keep going down. We get all these from the lithosphere, and that's pretty cool. Remember, as I said, we are a carbohydrate-based life. Now, I hope that made sense. Just a bit of information there about how they might interact. If you have any questions, feel free to ask them in the comments below, and we'll get back to you as soon as we can. Alright, see you later. Thanks for hanging around.